Okay, binomial expansion. When we did this before, we used Pascal's triangle with it. Ye old Pascal's triangle. If you remember, Pascal's triangle starts with a 1 on the top. Okay? And then every row beneath it starts with a 1 and ends with a 1. So you always see 1s on the outer. And does anyone remember how we find the numbers that are inside? You add the 2 that are above it. So like this 3 we found by adding 1 and 2. This 10 right here we found by adding this 4 and this 6. And I mean, it could continue on forever. These numbers in Pascal's triangle you could actually find using combinations as well. So you can see how combinations, remember, is what we learned last time. So all of these numbers are different combinations. Combination of 0, choose 0 at the top, and then 1, choose 0, 1, choose 1. You can see this row is 2, choose 0, 2, choose 1, 2, choose 2, 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. All the way down. The next one you would start with 6, choose 0, and then 6, choose 1, 6, choose 2, 6, choose 3, etc., etc., etc. Everyone notices the pattern that's following? See a pattern? Look at your face, Mason. Okay. The top row, we call this the 0 row. And then the one after that we call the first row, the second, third, fourth, fifth, etc., etc., etc. There is an important relationship between the powers of binomials and combinations. The numbers in Pascal's triangle can be used to find coefficients in binomial expansions. For example, the coefficients in the expansion of a plus b to the 4th power are the numbers of the combinations in the row of Pascal's triangle for n equals 4. I'm going to highlight that. So when you have a plus b to the 4th power that you're trying to expand, those coefficients we would find in the row for n equals 4. So if you look at n equals 4, those are going to be 4, choose 0, all the way down to 4, choose 4, which are the numbers 1, 4, 6, 4, 1. You can actually see them here. 1, 4, 6, 4, 1. Okay. We're going to practice one full binomial expansion using what we've learned before. Okay, we've done this before. And that's where we just grab the coefficients from the triangle. We write out how our variables and our numbers kind of adjust as they go down throughout the expansion. So if I see the first one, which says x minus 2 to the 5th power, that's telling me that I need to look for the row that's n equals 5 in my Pascal's triangle. So n equals 5. So if I look at n equals 5, that's going to be this row right here. So I'm going to need these 6 numbers for my binomial expansion. So remember how we did this before? We kind of left some space in between them. So 1, 5, 10, 10, 5, 1. Is this feeling familiar? Or anyone having deja vu? Okay, all right. And then we took our first term of our binomial, which our first term is an x. Bless you. And do y'all remember what exponent we start that x with? X to the what? The 5th power, right. This first term starts with this highest exponent here. So it's going to be an x to the 5th. And then it starts working its way down. So the next one would be an x to the 4th, x to the 3rd, x squared, x to the 1st, and at the end we have an x to the 0, which technically x to the 0 is just 1, but we'll simplify that in just a second. And then with the second term, so the second term is actually a negative 2, it's not just a 2. We start that with the lowest exponent possible. What exponent would that be? 0. Good memory. So the negative 2 starts with a power of 0, and then that one starts working its way up as we do the expansion. So we'll have negative 2 to the 1st power, negative 2 squared, negative 2 to the 3rd, negative 2 to the 4th, and negative 2 to the 5th. Okay, and then we did a little bit of simplifying on each of these. So if I look at that first one, 1x to the 5th times negative 2 to the 0 power. Negative 2 to the 0 we already know is what? Yeah, it's 1. Yeah, that's just 1. So So this is actually just 1 times 1 times x to the 5th. What would that simplify to? X to the 5th. Honor, we gotta lift our head. Thank you. You're missing out. Okay, and then for the next one, we have a 5, we have an x to the 4th, and we have a negative 2 to the 1st power. What would that simplify to? Negative 10, x to the 4th. Good job. Okay, and then for the next one, I see a 10, I see an x to the 3rd power, and I see a negative 2 squared. Does anyone know the value of negative 2 squared? It's 4, yeah, because it would be negative 2 times negative 2, which is positive 4. So I really just have a 10 times a 4 times an x cubed, which would turn into positive or negative? Positive 40x cubed. Good job. So this is ringing a bell, slightly, for some people. Okay, for the next one, let's see, I got a 10, I got an x squared, I have a negative 2 to the 3rd power, which would simplify to negative 8. Very good. So I got 10x squared times negative 8. Altogether, that's going to simplify to negative 80x squared. Very good. Okay. Let's see. I got a 5. I got an x to the 1st, and I have a negative 2 in parentheses to the 4th power. Negative 2 to the 4th power would be negative 2 times negative 2 times negative 2 times negative 2, which is 4 times 4, which is 16. And then I got a 16 times 5 times an x to the 1st power. 80x, good job, right. 80, and then you don't have to write that x to the 1st power anymore, you can just write x. And then for the very last one, I have a 1. I have an x to the 0, which actually is equal to also 1, very good. And I have a negative 2 to the 5th power, which would be still a negative 32. Negative 32. Very nice. Okay. So that's how we did it before. Okay, and that's how you would do maybe a full binomial expansion. But really today we're focusing on finding just a specific term of the binomial expansion. Just a specific term. And we're going to try and do it using combinations. Okay. Okay, this one says to find the 3rd term. Let's get rid of that. Where's my green one? We want to find the 3rd term, just the 3rd term, who cares about all the others, in the expansion of x minus 2y to the 5th. And we're going to try and do that using combinations. So since this is the 3rd term, I'm literally going to write out 3 blanks to write in. I don't care about the 4th, 5th, 6th, 7th, however many others there are. I just care about getting to that 3rd term. Okay, so first thing I know is that if it's an x to the 5th power, thinking about n equals 5, let's remind ourselves what that n equals 5 row looks like. It's going to start with 5 choose 0, 5 choose 1, 5 choose 2. So we're trying to do it with combinations instead of having to use my Pascal's triangle every time. Then you don't have to remember Pascal's triangle. So I know at the beginning I'm going to have 5 choose 0, 5 choose 1, and then this one would be 5 choose 2. So I'm really focusing in on what this one's going to be because this is my 3rd term. These two just help me get there. Okay, and then I'm going to have my x, my 1st term of my binomial, with my highest exponent. So it's going to have an x to the 5th. It's going to have an x to the 4th, and then this one, my special one, will be x to the 3rd. This is the one I care about. Okay, and then my 2nd term of my binomial would be negative 2y to the, it starts with which exponent? 0. And then this one will be negative 2y to the 1st, and then this one will be negative 2y squared. So again, we are focusing on what this one simplifies to. So do I even need to bother simplifying the other ones? No, because they don't matter because all I care about is my 3rd term. Okay, so first thing I'm going to do is I'm going to simplify my 5 choose 2. We've got our little combination formula over here if we need it. This first number, remember, that is your in value, and the second number is your r value. So let's see, that would be 5 factorial over 2 factorial times 5 minus 2, which would be 3 factorial. How much of that 5 do I want to expand? Enough to cancel the 3. So 5 times 4 times 3 factorial. Bless you. On the bottom, 2 factorial, remember, that's just 2 times 1. Cancel out the 3. Good. So if you think that's really just 20 over 2, what's 20 over 2? 10. Bless you. Okay, so I know at the beginning I'm going to have now a 10, an x cubed, and a negative 2y in parentheses squared. 10, an x cubed, and a negative 2y in parentheses squared. When you have a negative 2y in parentheses squared, that squared actually goes to both of these. So we'll have the negative 2 that's squared and the y that's squared. If the negative 2 is squared, what's it going to turn into? A 4. So this is now a 4. So we'll have 10, an x cubed, a 4, and a y squared. So the very next step should be my final answer for my third term. What's that going to simplify to? Yep, 40x cubed y squared. Very good. This is my third term in my expansion without having to expand the whole stupid thing. The whole beautiful, lovely thing. Okay, the next one, asking us something different, but still we're going to kind of try and find it in the same way. It says to find the coefficient of x cubed in the expansion of 2x minus y, 2x minus y to the 7th power. Coefficient of the x cubed term in that expansion. Let's think about this. I'm going to start just kind of drawing out some blanks. If it's a 7th power, I know at the beginning I'm going to have a 7 choose 0. And then my next one would be a 7 choose 1, 7 choose 2. We might not need all of this expansion. Let's see. If I'm starting with my 2x to the 7th power, at the beginning I'm going to have a 2x in parentheses to the 7th, and then I'll have a 2x in parentheses to the 6th, and then a 2x in parentheses to the 5th. Dang it, sad, I do need more. This one will be 7 choose 3, and then 2x in parentheses to the 4th power. Good. The next one would be 7 choose 4, and then we'll have a 2x in parentheses to the 3rd power. All right, that's the one I got to focus in on. Okay, so I found this is the one that's going to have the x cubed. So this is our important one. Okay, so I did do my first variable, my first term with the exponent. Now I need to work on my negative y with that exponent. So what exponent will that negative y start with? 0. Good. And then we'll have negative y to the first, negative y squared, negative y to the 3rd power, and then lastly negative y to the 4th power. Okay, so this is the term that will have my x cubed. Technically it does just ask for the coefficient, but this 7 choose 4 is not going to be the full coefficient. I can tell it's not the full coefficient because I also have coefficients on these that are going to affect it. But let's first figure out what 7 choose 4 is equal to. On the top will be what factorial? 7 factorial, according to my formula. On the bottom we'll have 4 factorial, and then 7 minus 4, which would be 3 factorial. How much of that 7 do we want to expand? Enough to cancel the 4, right. 7, 6, 5, 4 factorial. On the bottom it'll cancel with this 4 factorial, but then we still have 3 times 2 times 1. The 3 times 2 on the bottom, that's just equivalent to 6, so I could cancel that with my 6 on the top. So all I have left is 7 times 5, which is 35. Good. Yep, I wrote 3. I need to write the 5s. So now I know this has a value of 35. So it's 35 times 2x to the third power times negative y to the fourth power. So this would be 2 to the third power x to the third power. 2 to the third power x to the third power. And this one is negative y to the fourth power. Okay. What's 2 to the third power? 8. So now we have 35 times 8 times x cubed. What is negative y to the fourth power going to simplify to? Positive y to the fourth, right? Because a negative times a negative would be a positive. Another negative times a negative would be a positive. So if you have 4 of those, it's just positive times y to the fourth. So if we're caring about just the coefficient, we really just need to figure out what that 35 times 8 is. 280. If you want to write the rest of it, you can, but really the answer is just focused in on this 280 right here. Honor, lift your head. Pull up. You need to take your backpack off. You're too comfortable. Oh, it is off. Okay. Yeah, go get water, dude. You're going to come and ask me about this later, and I'm going to say, no, thank you. Okay. Next term, we're finding the fifth term. Fifth term in this expansion. Y'all want to see if you can do it by yourself? Oh, shoot. Fifth term from the end. Even better. Is it the fourth term? Yes. Let's see. Okay. I know at the beginning, I'm just going to start by doing my variables. I'm going to have x to the 9th, x to the 8th, x to the 7, x to the 6, x to the 5, x to the 4, I'm running out of room, x to the 3, x to the 2, x to the 1, x to the 0. Okay, so fifth term from the end. 5, 4, 3, 2, 1. Is this one? Was it the fourth term, Danny? No, it wasn't. That's not the fourth term. 1, 2, 3, 4, 5. This is the fifth term from the end.
I was thinking 9 minus 5. But that would also be wrong.
Okay, that's the one we got to focus in on. Okay, so we also need to think about, for my combinations, what's it going to start with? 9 choose 0. 9 choose 0, 9 choose 1, 9 choose 2, 9 choose 3, 9 choose 4, and then this one would be 9 choose 5, right. Take your hood off, you're getting too cozy. Yeah, take it off, dude. You're too cozy, you're too warm and comfortable. There you go, we want to be uncomfortable to stay awake. Okay, then we also need to do our 2. The 2 is going to start with which exponent here? 2 to the 0, 2 to the first, 2 to the, 2 to the, 2 to the, and 2 to the 5th. It's not negative, so I'm not worried about those parentheses. So what's the first thing I need to do then? Figure out what 9 choose 5 is. We're going to expand enough of the 9 to cancel that 5 factorial on the bottom because it's the larger. And let's see, my 4 and my 2 can cancel with the 8. The 3 could simplify with the 9. So we really just need to do 3 times 7 times 6. 21 times 6. What is it? 126? 126. And then we got an x to the 4th. And we got a 2 to the 5th, which is 32. Very good. So for my final answer, we'll have, bless you, 4032 x to the 4th. Yeah, goodness.